Hi everyone, thanks for tuning in again, and I'm delighted to introduce our birthday man today. Congratulations, Art. I couldn't help myself. Apologies for that.
Thank you. Thank you.
Um, Art is the business development manager for printed electronics at Henkel, and he will tell us how they enable smart surface designs with 3D printed electronics. Art, with that, stage is yours.
Exactly. Thank you, Christopher, for the introduction. And thank you for having me, first of all. And welcome to the audience. I hope you like the presentation. I'll walk you through, indeed, enabling smart surfaces design with 3D printed electronics. First, I'll show you a short disclaimer. Just take a minute to read it through. That's part of our policy. So, all right. So let me first quickly introduce myself. I'm Dutch, as Christopher said, business development manager for printed electronics in Europe. I joined Henkel in 2012 as a regional account manager for electronic materials. And then I joined our automotive team at Adhesives Automotive, mostly working on thermal management materials and working on the mega trends like e-mobility and autonomous driving. And that's also very interesting now for printed electronics. We have a dedicated team within Henkel working across our adhesives business. So as you might know, Henkel is quite a large adhesives supplier, market leader in adhesives. So our ultimate goal with these 25 people is to leverage and to work on projects for printed electronics across these divisions. So that's within automotive, within medical applications, packaging, so throughout our businesses. So what is driving us when it comes to 3D printed electronics? Well, basically, the world is really connecting. And so like there's a large need of data generation. People got connected and things got connected, what we call then the Internet of Things. But in the meantime, now we're speaking about the Internet of Everything. So creating a network that connect people and connect things, processes, and data. And also even we are used to that with our mobiles and handheld devices, but it's very much into business-to-business applications right now. And we see a big potential there within the next few years on to make dumb surfaces, like simple surfaces, into smart surfaces. So within Henkel Printed Electronics, we truly focus on a few applications areas. Here you can see smart surfaces in automotive. So the car interior is heavily changing, driven by, of course, the megatrend autonomous driving. We are working on smart healthcare. There's an increasing need to digitalize healthcare, and there's a growing need for data on that. We are working on smart adult care, so we call that smart diapers, for example, and we're also working on smart 5G antenna systems, and last but not least, also to make consumer services very smart. What does it mean, printed electronics, or what are the really the advantages of printed electronics in this area? As you might know, it gives you a great design freedom. It's very thin and flexible, and that makes it also very easy to integrate in devices. And it's also lightweight. We're talking about printed foils, and printed electronics is truly an additive process. And that makes it feasible for, of course, many substrates. So I'm going to walk you through a few technologies, so application technologies for our inks and printed electronics. And of course, as the title of the presentation says, it's enabling 3D printed electronics for design and application possibilities. And that means like surface integration by screen printing and thermoforming. There are quite a few presentations already done on this, like in